Hey guys, I'm making the instructional video. I'm gonna do a think aloud of the redo of the EcoColumns analysis. I tried my best to do this on screen capture, but it was like just not working for me. Either way, pay attention to this so we don't make the same mistakes on the redo and you get all 5 questions right, or 4 of them. So on the very first one, describe why environmental field scientists have to monitor aquatic ecosystems. We're just thinking that they're fragile ecosystems. They're usually small ecosystems, and any sort of disturbance can disrupt the ecosystem. So that's why these field biologists are out there all the time doing the exact same monitoring and water quality indicators that we did. So scrolling down here, so looking at this map, which one of these would have thermal pollution but not conductivity? Don't forget nuclear power. We'll talk about this more later with another unit. But with nuclear power plants, those the cooling towers, if they don't do their jobs appropriately, the water can be superheated and that'll cause thermal pollution. Technically, for runoff of a city, if it's impervious ground cover, that would also cause thermal pollution. But notice the question says would not cause conductivity. That runoff of the developed concrete, the impervious ground cover runoff would also raise conductivity. So that's why C is the answer for that one. When there's, are you listening? When there's runoff of impervious ground cover, that's going to raise turbidity, that's going to raise conductivity, that's going to raise thermal pollution. That might even increase with nitrates and phosphates of the nutrient pollution. So impervious ground cover runoff is a huge problem. Speaking of nutrient pollution, we're thinking agriculture. So for number 3, high nitrate and phosphate is going to be on these agricultural fields, manure lagoons, the fertilizer, the animal waste. That's all going to have nitrates and phosphates, and that's going to cause a dead zone eventually. We'll talk about that more later. So an increase in turbidity would cause a decrease in photosynthesis, but that's not on here, a decrease in net primary productivity. Remember, after the producers do photosynthesis, what's left over is NPP. Either way, if the water is too cloudy, those producers cannot do photosynthesis, which means the NPP will be decreased as well. Finally, for this one, students had an issue with this one. If I read it, I noticed that for the ones that are black, the ones that are solid, that's where they thrive. The ones that are shaded, the grayscale ones, that's where they can tolerate it, but they can't thrive. So on this one, where the brook trout thrive, they can tolerate a pH of 4.5 to 5, but they thrive at a pH of 5, it's 5.5, 6, all the way to 7. So your analysis is also going to have this is the same exact picture diagram, but for a different species. So make sure you can interpret this and you'll do fine. I hope this video is helpful, and I hope you get all 5 or at least 4 questions right on the redo. Bye.